In this video, we'll move to the third and final step of our sequential multiple regression example. We previously looked at mother's education alone in Model 1, and then we added school quality in Model 2 as we began to work through the sequential chain of effects. Now, in Model 3, we're going to add study hours as our final predictor variable. Okay? So, here's our ANOVA table, and in it we see that mother's education, school quality, and study hours as a set has a statistically significant effect on grades, with an F with 3 and 396 degrees of freedom equal to 22.463 and a p-value less than 0.001. Notice again that as we added a predictor, the degrees of freedom regression increased by 1 and the degrees of freedom for the residual decreased by 1. Okay? So here we see again the overall effect is statistically significant, but how large is our R squared? Well, in the model summary table, we see that mother's education, school quality, and study hours, again as a set, accounts for 14.5% of the variance in grades. The addition of study hours has increased the total R squared by 0.004 or 0.4% of the variance in grades, which is not statistically significant, with an F with 1 and 396 degrees of freedom equal to 1.875 and a p-value of 0.172. Now, this reflects the variance in grades that's uniquely due to study hours, beyond the effect that's due to mother's education and school quality. Okay? Now, if we want to calculate the F-test for that change in R squared by hand, it's just, again, the R squared for our new model, our current model, minus the R squared for the previous model, divided by the number of variables in our new model minus the number of variables in the previous model. All of that over 1 minus the R squared for our new model, divided by the n minus the number of variables in the new model minus 1. If we plug in the variables, all the values for those, we get our F for the change in R squared is equal to 0.145 minus 0.141 divided by 3 minus 2. All of that divided by 1 minus 0.145 divided by 400 minus 3 minus 1, or 1.875. Right? Now, the first degree of freedom for the F change test is the K new, the number of variables in this model, minus K old, the number of variables in the previous old model, Model 2 in this case. So that's 3 minus 2, or 1. The second degrees of freedom is just the degrees of freedom residual from the overall ANOVA table, which is n minus the number of variables in this model, minus 1, which is 400 minus 3 minus 1, or 396. Now, we can write that out as the F for the change in R squared with 1 and 396 degrees of freedom equals 1.875 with a p equal to 0.172. Now, this change in R squared of 0.004 is the total effect for study hours, expressed as a variance, right? It's the variance in grades that's uniquely related to study hours after controlling for the preceding variables, mom's education and school quality, but before we've added any additional subsequent variables. Let's check that in a Venn diagram. Now, in this Venn diagram, we see the increasing R squared as we add predictors. In this case, when we add study hours, the previous R squared just grows a little bit, that sliver of green all the way over, right? Now, that increase in R squared, that sliver of green is equal to, the area of that is equal to 0.004, or again, 4% of the total variance in grades. Mathematically, we can see that as the R squared for grades predicted based on mother's education, school quality, and study hours equals the R squared for grades based only on mother's education plus the change in R squared when we added school quality plus the change in R squared when we added study hours. This solves to 0.145 equals 0.128 plus 0.014 plus 0.004, again within rounding. Now, look closely at this variance, right? It's the variance in grades that is shared between study hours and grades, right? It's that overlapping variance between study hours and grades. But it's also shared with school quality and mother's education. But notice how, based on our sequential model, credit for that variance was already given to those other variables earlier in the model. Let's see that again just to be clear, right? We're talking about that variance. Now, in this case, the model determines who gets credit for variance shared by multiple predictors. This is how sequential multiple regression addresses that who gets credit for C, that who gets credit for that overlapping shared variance question, right? Again, this is what differentiates sequential multiple regression from simultaneous multiple regression, in which case none of the individual variables would specifically get credit for that part of this shared effect. In contrast, our model says that mother's education and school quality influence or cause study hours. And so any variance they share is due to the effect of those variables. Again, we're not just saying that they're correlated in some way. Our model says it's due to mother's education and school quality. So notice, as we add variables to a sequential regression model, the change in variance that occurred in previous steps, of course, stays the same. And remember, each of those is the total effect of that variable on grades, again, in terms of variance. The total effect of mother's education is still 0.128, and the total effect of school quality is still 0.014. And now we see that the total effect of study hours is 0.004 or 0.4%. Pretty cool, right? Okay, let's stop at this point. In our next video, we'll finish our examination of Model 3, starting with the coefficients table. All right? Bye for now.